All right, so the other day we looked at communication matrices. So remember communication matrices, we had, first of all, we had one-step communication matrices. So I'll just go back here. So one step shows how, where you can, who can directly talk to someone else. So that's what one step is. When we talk about two steps, it's how you, two-step communication, which is when we square the communication matrix, that's telling you how many options of two-step communications you have between two people. So what that means is I send a message to someone who then sends it to the person I want it to go to. That would be done in two steps. So the two-step communication shows you how many options there are of that. So we are going to look at here, this next lesson, we're going to be looking at some different types of communication matrices, but these are exam questions. So they are taken from the Year 12 exam, but this is, you are capable of doing it. They don't learn any other theory other than what you've just learned. So let's have a look and go through these together. So the main computer system in Eleanor's office has broken down. 5 staff members, and I'm just going to call them A, B, C, D, E, are having problems sending information to each other. So the matrix M shows the available communication between two staffs. So what they've told you, we know that matrix M is actually equal to one-step communication, okay? Because it's who can directly talk to each other. So if you look down, you can see this one-step communication matrices only has ones and zeros, which is what we call a binary matrix. So we can see that there. Now, in your exams, they always are going to state this stuff, and it's just information that you know. It's going to say that a 1 means that that someone can communicate with someone else. So they're just explaining it out. It's you already know that, but they have to put it in there, okay? So you don't need to worry too much about that. So the question here for part A is, which 2 staff members can send information directly to each other? So if you have a look, if you looked at A can send to B, but B cannot send to A if you're looking at this one. So it's not going both ways. So if we're looking in here, is there one where there's both options? So someone suggested C and D. All right, so if we look along C can talk to D. Now if we go along the D row, no, we don't have it. It can't talk to C either. B and D. What about B and D? All right, so B and D. So here's B and D, and then when I go, yeah. So can we see that one? I'll change the color there. So if I go along B, it can talk to D. If I go along the D row, it can talk to B. So there was a 1 with both. So we just have to write B and D. So in the exams, you can just use the letters because they define those names as letters. So that's fine. If you wrote the names, that's fine too. But, save yourself time and just write B and D. All right, let's have a look at this question. In total, it's 3 marks, but we're just going to be looking at the part that you guys can do. So it's just the 1 mark. 1 mark in Year 12 is a lot. So on the exam. So we want to make sure we can get every 1 mark that we can get. All right. The main system in Eleanor's office has broken down. Oh, so we've got the same. Oh, that question's just repeated. Oh, yeah, sorry. That's the same question. So we'll cancel that out. So what we're going to move into also today, and this is new, so it's not in your textbook, but we are going to be doing it because it comes up in Year 12, and it's a more advantage if we go through this and practice this now, because you will be pushed for time next year. So let's have a look at a little bit of the theory. So we've got a binary matrix, which is just ones and zeros, which is what I told you. A communication is a type of binary matrix. So if you want to write that, a one-step communication matrix is a type of binary, communication matrix is a type of binary matrix. because it just has ones and zeros. But a step 2 communication isn't, because we see other numbers, yeah, don't we? So just a one-step communication. So we can see we can have ones and zeros. And remember also another type that we knew, remember an identity matrix is also a type of binary, is also binary. And remember, it has ones on that leading diagonal and zeros elsewhere. So there's none of these ones above is an identity. So that's why I just wanted to put that one in there. All right, so we just need to know what that, you could get quizzed on that, or you'll get quizzed on the facts of, you know, is an identity, what type of matrix is an identity matrix? And you could say it's square, it's binary. Yeah, so things that you need to, just facts that you'll need to know, you could get quizzed on that. So the next thing we're going to look at is called permutation matrices. So if we think about the word permutation sort of means you change. It's a changing thing, right? It moves around and you're changing into something. So a permutation matrix, what it does, it moves around the element. So maybe we write this. So it moves around the elements in terms of it reshuffles, it can reshuffle them. Or you might want to say reshuffle them. So sometimes we need that because it's, you know, a certain calculation's not going to work if the info is a certain way. We might want it a different way. Or we might use permutations to move around data, to shuffle it around. So what we're going to have a look at here is we're going to have a look at these matrices here. So we've got a permutation matrix. An identity is a type of permutation matrix, but let's have a look at this one. So we have this matrix here, which is a 3x1, 3 rows, 1 column, and it has letters, and then we have a permutation matrix. Now, this permutation matrix is a 3x3. Okay, so what we're going to see, if we type this permutation matrix into the calculator and we times it by this letter 1. So first of all, let's have a look. Is this multiplication, is it defined? Can we do it? Yeah, so then remember we say that's defined. And remember, we get the order of the first one and the last one. So that makes sense. That's what it's showing there. So what we're going to see, if we do this on our calculator, we're actually going to see the letters, how that permutation matrix moves it around. So let me just do it here on our calculator. So I'm going to type in the permutation first. So here I go. I've got a 3x3. So be careful. Got to make sure the numbers are correct. So we've done that. We pop this in like this. You can see we're going to times it by the 3x1. So remember, 3x1, you have to pick like that. Now, you can put letters into your elements. It doesn't matter. So I started off with tar. Tar. And when it's times by that permutation matrix, you can see it moved it around. The T went down to the bottom, and I got, I got the letters RAT there. So what you could do is, if I raise that permutation matrix to a power, so I'm going to raise it to 2, that's like me going to do it 2 times. So it'll shuffle it to that RAT, and then it'll shuffle it again. So when I do that, I go back to tar. So because it's just shuffling, that's what it took. So if you are asked to apply the permutation, say 3 times, you just pop it to the power of 3. Now, why can I raise that? That permutation to a power? What about that matrix makes me allowed to do that? It's a square. Good. So there's what a permutation matrix is going to be used for. Okay, so let's have a look at this example. So it's asking me to find a permutation matrix that takes this column matrix from this to that. So if you think we've got a 4 by 1 and we want to get a 4 by 1 answer. So what size? So you think about it, we're going to do a permutation by another matrix. Say I'll just call this the word matrix. Say we're going to do that. If this is a 4 by 1 and we want the answer to be a 4 by 1, what does that permutation matrix need to be? A what? So remember, these numbers have to be equal. So it's got to be a 4, but remember, we take from here. So what's it going to be? A 4 by 4. So we're going to see a 4 by 4 matrix, okay? We're going to times it by this letter matrix. And then we're going to, it's going to give us this answer here, D, C, B, and A. Okay, so when we do, remember when we do manual multiplication, so really we're going to get this, remember this is the element here. If you think about this element was found, so this element was found by multiplying the row 1, because it's in row 1, and it's with column 1. So what that means is, because this is 1, 1, we're going to go with the row 1 and down the column, this column 1. So we're going to always be multiplying by that column. Now, if we multiply manually, so we know the number here, so we're going to have 4 numbers across here, okay? So the first number is going to get multiplied with A, and then it's going to produce, then we'll add it with. If I don't want something to show, I don't want the value there, I don't want it, what could I multiply it by? What does something multiplied by it will give nothing? 0. No, 1 would give itself. Would 0 give nothing? Yeah? So if I put a 0 there, it's going to be 0 times A. It would be like this. We'd have 0 times A plus, do I want the B to show? What letter do I want to show? I'm going to help you out here. So which one do I think? Oh, sorry, this should be D. Oh, no, that's A. Which letter do I want to show first? The D. See here? So I'm going to have plus 1 times D. So really, I want 0, 0, and I want the 1 to show there. When I'm in row 2, so say this one was found by going row 2 with column 1. So I'm going to be in this one. So I want which letter to show? I want C. So where does C occur? On the first or the second or the third? So can you see if I put a 1 there, it will show the C. Yeah? And then, okay, what's the next one? This guy is row 3. What letter do I want to show? So I'll put a 1 here. Would you agree? Yeah. So we go like that and 0 elsewhere. And then the last one, we want A to show. So which one do we want a 1 straight off? Would you agree? And then 0s elsewhere. So what they've asked is for this permutation. So here is our answer. This is our permutation matrix there. And if you test it out on your calculator, you're going to see that. Okay?